So in this project you are going to see the coding of PIC microcontroller family in embedded C using two tools. One is MPLAB and another one is Proteus. Let's start programming. So now in this project we are going to see about the coding of the PIC microcontroller family, and for this coding we are going to use embedded C program, and so we will start with this PIC or 12F1501 family. So the main features of this microcontroller is it is 8-pin flash microcontroller, and it has 8-bit it is an 8-bit microcontroller, and it has an internal oscillator whose frequency is 16 megahertz to 31 kilohertz, and it has an operating voltage ranges from 2.3 volt to 5.5 volt, and so at the max you can keep it at a fixed value of 5 volt, and it has a pin of from it has only one port, which is port A, and this port A has 6 pins, which is RA0 to RA5. And it has two registers, which is tris and lat register. The thing what we have to keep in mind is in these two registers the pin 3 will be in a disabled state, so we will not give any input to this pin 3 alone. Next, in this tris register we can set the register in input mode or in output mode, and if I give a value of 0, that is if I don't give any value, it will be taken as digital 0, and this 0 it refers to the pin to be set as an input pin, and if I set it to 1, it means that the pin is set as an output pin. And in the lat A register again we have two kinds of input. One is an input 0 and another one is input 1. So if I place it as 0, it means like the voltage is a low voltage, which is a 0 volt, and if I give a high input, which is 1, this 1 will be represented as a high voltage of 5 volt. Okay, and so we are going to use these two tools, which is MPLAB and Proteus, and now we can start the programming.
Now we can start with the project, and we are going to give the file as a new project plus test. This is a small name. For that, first I'll give this as an embedded microchip, which is a standalone project. Next.
So now we can start with the coding, and now for this we can define the internal oscillator frequency, which is the system clock frequency, which is 500 kilohertz. So I am commenting it as system clock frequency, and within this hash include void main, and I can so there will be no return values. So now, so first the tris A will be set to 0, B. Everything is 0 because we need only input. So it is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 pins. So in all these 8 pins I have set it to 0. 0 means we are going to take it as an input pin. Okay. So this is configuration of port A. Okay, so next I'll give a while value, while of 1. So this while will get executed until this value is true. Okay, so now I'm going to assign the latte value 0 B 0 0 0 0 2 3 4 5 6 7. So the last digit alone will be 1. That is RA naught is 1. So here the RA naught is set to 1. So that is RA naught is high, meaning RA naught is high. I'm going to give a delay. Next I'm going to enable the second pin. So for enablement of the second pin, so the first pin will be 0 and second pin, that is RA1 alone, will be 1. So next is RA2, RA3, RA4, RA5, RA6, RA7. Correct. So second pin alone is enabled to. Previous case RA naught is high. So here RA1 is high. So this process we can continue till the last pin, that is RA5. So now we can continue the coding, and so now RA1 is set to high. Similarly, we can set RA2 also to high. RA1 will make it 0 and RA2 to high. So now RA2 is high, the delay. Then after that, now after this RA2 high, RA3 we will not make it high. We'll make RA4 high, because RA3 is should not be enabled, or no value should be set for RA3. So it is 0 1 2 3 4. So this place. So similarly we can do for the RA5. So by this coding is over. After completing this, we can build it. So once the build is successful, we can start with our Proteus. So now we can start with the Proteus. Open a new project. So for this also we'll give the name as test. The folder I already prepared a folder for this, which is in simulation. We can give the name as simulation, the folder name as simulation, and we can select that folder. Okay, so we'll give next. So it's a default one, and next, finish. So a new page will open wherein we need to select some of the devices. So first is we have to take the PIC 12F1501, which is at a microcontroller, and we need a few LEDs. For enabling LED, I'll give LED red. Okay. So now we can start to place our components one by one. So in order to zoom, you can give the zoom in option. Still no zoom in, and okay, now it's comfortably placed. Now we can place our LEDs. And LED. So how many? 5 LEDs we need to place. So 5 LEDs, right? R1 for R0, R1 for RA0, RA0, RA1. Next for RA2. Next RA4 and RA5. So now the connection part. So after this we have to give the ground. Before that I'll remove all these names and all. It will be a disturbance to us. I'll place this D3 somewhere else. Place it D3 near to this. Next D4. So totally 5 LEDs. So we can ground all these LEDs. So further we have to go to the terminal part, ground. Just connect the ground, that's it. Yeah, babies at home are a big noise, creating noise. சரிம்மா சரிம்மா சரி. Okay, so everything is grounded. So now we can connect this to our code. And we can run this. Should work. RA not RA1. See, I missed out RA2. RA2 we need one LED. சரி. இப்போ பால் கொடுத்தேன்.
பால் கொடுக்க பாலுக்காக இல்லை, பிள்ளை வேணாம், நீ எடுன்னு சொல்லக்கா இல்லையா?
So one mistake I have done, see, RA3, stop this, see RA3 is activated here. You delete this wire, all these wires we will remove. RA3 will be disabled all the time. So now we'll run. See here? Super. So this is the end result. We'll get a simultaneous enablement of LED. Okay, anyway, thank you for watching.